Electric vehicle has combination of the different energy source, that is fuel cell, batteries, capacitors, and power to power an electric drive system. And the main electric and hybrid electric configuration to energy storage devices, one with high energy storage capability, that is main energy system, another with high power capability and reversibility called rechargeable energy storage system. So, and it started to replacing conventional vehicles in case of USA, Europe, and Asia also. Now, the increasing of conventional automobile is causing harm and environment, human life, as these automobiles burn petrol, diesel, and natural gas, produce carbon dioxide and sulfur dioxide, uh, oxide of nitrogen as harmful exhaust components. This is the overview of electric vehicles. Here, source charger and energy sources, batteries. This is the drive control signal which control the power converter, and power converter control the motor, and that motor is control drive and wheels. This is the known as a drive train. Some advantage of electric vehicles: it is environment friendly, reduce energy demand, and energy efficient, low electromagnetic interference, high initial torque density and high power density, high robustness in different atmospheric condition, high reliability of long range. When it is control of the DC to DC converter, power flow subject to the wide voltage variation on the converter input. This is some limitation of the electric vehicles. That means some electric vehicles have short range for driving. When in case of high large range, we cannot control that one. Initial cost is steep. Selection of energy source is still under development. Difficult to use high torque require vehicles. The another thing is very much require charging station for battery electric vehicles, less acceleration, disposal of batteries, contain toxic heavy metals. In such type of EVs, charging time is taken charging time is more. Electric vehicles and historical background. I will discuss something that I already discussed that time. I don't know you can got it or not. Electric vehicles are prevalent in nearly 20th century and advanced in internal combustion, especially electric starter. The greater range of gasoline car, quicker refueling time, and growing petroleum infrastructure, which led to the decline the electric propulsion. 1801, the steam power carriage was built. Then the first battery power EV built on 1834. The over 50 years later, the gasoline power ICE vehicles was built in 1885, and the EV were also the better performance and using from 1930 to 1950s. And the energy crisis 97 to 80 brought the renewed interest of electric vehicles. Further global economics and recession of late 20s called abandon of fuels insufficient supers. Now uh, the revival EVs due to the increasing concern energy conversion and environment throughout world. There are summarized. EV offer the high overall energy efficiency over the IC vehicles. The efficiency of the IC vehicle can be 30 to 35, but here the peak power from battery corporate peak efficiency around 90%. And EV is enabled to load equalization power system by recharging the electric vehicle in night. The power generation facilities can be effectively utilized, contributing the energy saving and stability of power cost. EV also shows the zero exhaust emission and to improve the dynamic performance and all range of advanced electric vehicles such as hybrid or plug-in hybrid or fuel cell vehicles can be proposed. And apart of the advantage, EV is also some disadvantage like large battery charging time, lower flexibility, limited dynamic performance. Now, I am discussing vehicle drive system versus industrial drive system. Actually, industrial drive system that also be depends on the power modulator and to motor. The power modulator control the motor speed, and then the that controlling uh, feedback to the tachogenator or sensor. It will be whole system, and it will be by using by the controller control the current or voltage and send it to power modulator. In this total whole system is industrial system, industrial drive system. That industrial drive system are nowadays every place is generating a station, steel plant, cement mill. So many places are used for that. So electric vehicle drive system also similar to the that. That means it is also power converter, then electric traction motor also or motor also used. So EV also usually required to frequent start of high rate of acceleration, deceleration, high torque, low speed, hill climbing, low torque. And now the electric vehicles and more difference between these two are given. Electric vehicle drives needs to offer 4 or 5 times to maximum torque, whereas the industrial generally offer twice to maximum torque. And electric vehicle drives to achieve 4 to 5 times of base speed highway cruising. And same case in industrial drives, it will be twice. In electric vehicles should be different according to vehicle drive profile, whereas industrial drives are usually based on the particular working mode. And that means electric high power density good efficiency map, and industrial also comparison between power density efficiency cost with the efficiency optimized at a particular operating point. EV has desired a high controllability, high steady state accuracy, and good dynamic performance multiple other than industrial drives. So these are the I will discuss different type of electric vehicles. Actually, the IC vehicles employs combustion engine for propulsion. Its energy source gasoline and diesel fuel. In contrast, the EV employs the electric motor, and the corresponding energy source are battery fuels, capacitor, or and the flywheel. There are different. There are three different. Mostly three different electric vehicles. One is battery electric vehicles, plug-in or hybrid vehicles, or plug-in hybrid vehicles, fuel electric vehicles. So I am starting about the battery electric vehicles. Battery electric vehicle utilize batteries as a sole energy source, and electric motor is the propulsion device. And battery power electric vehicles were one of the solution was proposed to tackle the energy crisis and global warming. However, the high initial cost and short driving range, long charging time, reduced passenger and cargo space, uh, the limitation of battery power of EVs. Now, some of four-wheeler EVs or Tata Nexon EV, Hyundai Kona, and Mahindra that are two-wheeler, and also two-wheeler also include for the startup, that also startup, and there will be planning to launch of this year. That this is the main components for the battery electric vehicles. This is the electric traction motor, this one, and this is the power electronic controller, DC to DC converter, thermal steam cooling, and this side where transaction battery pack, and this is the charging point, and this transmission and onboard. This is the onboard charger. And another thing is hybrid. Another is very important hybrid vehicle. That hybrid vehicle incorporates both combustion engine and electric motor as a propulsion device. It is adopt the gasoline uh, gasoline and diesel fuel as the main energy source and utilize batteries as auxiliary energy source. And HGV also can offer some driving range, that is over 5 km per refuel, and it mechanically combination of electric motor, low speed dedicated in city traffic, and conventional internal combustion to be used for outside the urban area. Now, HEB in India are using for this Toyota Pyrus hybrid and Honda Civic hybrid, Toyota and Maruti Suzuki. Another part, the most upgraded of HEB, that is known as a plug-in hybrid vehicle. It includes actually new battery charging system that can be fed from the externally, and the PHB referred to vehicles can use to independently on fuel or electricity, both them rechargeable from the external sources. It can be considered either battery electric vehicle supplement with an internal combustion engine to increase the driving range as a conventional HCV. And this also available in the Mahindra E Berito, BMW i8, and the Volvo XC90T8. This is the model, that is hybrid vehicle. It is only fuel tanks there is given. This is the main difference, and battery also here, and that is hybrid. That one also we are considering the battery is more upgraded to the hybrid vehicles. And this is the simplified architecture of electric vehicles. Battery, this is battery pack, and DC to DC converter to power converter to this transmission. And this is the bank, battery alpha capacitor bank also we can use, and battery pack. And this is the hybrid, there is a battery pack hybrid, and then this is the fuel tank. Hybrid, there are three types of series hybrid system, and series, this is the structure of series hybrid system. There is, this is called hybrid system because series, because of power flow in a wheel in a series. That is why the reservoir, engine, generator, and then charger, battery and flywheel or capacitor also used in charging, or it is controlled to the capacitor converter also. Converter control to the electric motor. And a series hybrid system can run a small output engine in the efficient operating region steadily, generate and supply electricity to the electric motor and efficiently charge to the battery. This is the parallel hybrid system. In parallel hybrid system, both engine and motor drive in the wheel. The drive power from these two sources utilized according to prevailing condition. So there is battery, and this side is reservoir. And battery, it will be uh, input of a battery means this voltage, it is input of a converter, and converter control the electric motor, and reservoir are control to the engine. These are two are connected parallelly. Parallel hybrid, that is power flow through the wheel in parallel. Series and parallel hybrid system. This is the most important. This is engine, and this reservoir to engine, and the generator. It is engine to. It is connected with generator. Generator connected, charger connected with the generator. Also, battery is connected. It may be charger, used to charger, and used to converter also. The converter give to the electric motor. Series parallel hybrid is parallel hybrid. It is that incorporate the power split devices, allowing to the power path from the IC wheel, and can be either mechanical or electrical. Another very important vehicle system is fuel cell electric vehicle system. The fuel cell electric vehicle main energy source is the fuel, and electric motor is the propulsion device. Since fuel cell cannot accept the regenerative braking, the battery is generally adopted the auxiliary energy source. A fuel cell hydrogen or oxygen produce the high chemical reaction. Fuel offers the low emission efficiency compared to ICA. So now fuel cell has been introduced long distance. It is used fuel cell system to onboard electric motor. The fuel cell vehicles are and hydrogen emits only water and heat. By the clean and high efficiency, reliable transportation facilities, FC becomes to important technology development of electric vehicles. In a fuel cell being the developed buses, boats, motorcycle, many other kinds of vehicles. Now another type of extended range electric vehicle. This is also similar type of hybrid vehicles. It is also hybrid vehicle range extend, and it is also one type of unique vehicles where battery and propulsion are charged, such as engine never required to operation vehicles when energy available from the battery. Now these are simplified architecture of range extend electric vehicle. This one here, range extend unit is given here, and this is the fuel cell. This is fuel cell and battery pack connected with the DC to DC, and DC to DC it will be used to for the power converter, means inverters. Another very important electric vehicle is solar electric vehicle. Is an electric vehicle power importantly completed direct solar energy through the solar array installed the top of the vehicles. Often photovoltaic cells, solar energy is converted directly into the electric energy. And since converted solar energy uh, that to electric energy, it will be the ACB's propulsion, electronics, communication, navigation, and security. Okay, and sensor may be used in this case in this solar electric vehicles, and this is the solar vehicles block diagram. Here, solar panel maximum power point tracker, and then it will be going to the buck boost converter and charge controller. After that, battery, and then voltage source inverter to BLDC motor, and then it's going to the wheel. Then improve the sunroof of, this is the improve. Oh, suppose you are considering one car, and roof of the car we are using the plate, the solar plate. We have to put in the, there are two way you have to do this. One, you have to use a charger, another you have to put in roof of the car. So that car, that time the sunlight will be given, it will be fall to the panel, and that panel converted the uh, energy to, it will be converted to the electrical energy. And this is the architecture of that simple architecture. Here will be ACB, this is similar, and this is the system architecture, grid connected EV PV charger. This is very important things. We are considering the 10 kV panels, PV panels, then PV MPPT converter DC to DC, then DC link to, it will be grid inverter, and this side it will be going to the charger, then it will connect it with the vehicles. That way you have to charge to the vehicles, and you have to connect the roof of the vehicles, then car, then it will be also converted to the electrical energy. Now there are different advantage and disadvantage of technologies is given here. Hybrid electric vehicles, it will reduce fuel consumption and emission, and possibility to recover energy. And its disadvantage is higher initial cost and component and availability, and the PHB impo- important to grid connection potential and reduce fuel consumption and emission. There are many higher initial cost and build complexity involving two powertrains. That means transmission energy loss will be happen. And another is BHB, use this cleaner energy, electric energy, zero emission vehicles, and it is short distance range. That is disadvantage. Short battery technology is still be improved. Okay, and fuel zero emission and very high energy efficiency compared to the conventional IC. Recover energy from regenerative braking, and no depends on petroleum, and higher, it is also higher initial cost, hydrogen generation, and onboard storage, security problem, availability, affordability, hydrogen refueling station. Another is solar technology, able to utilize their fuel power at any speed, do not require to the running weight, requires very low maintenance and no harmful emission. But it disadvantage is not the speed or power that regular cars have, can operate only sun, unless that will be not possible. Then I am discussing electric vehicle technology. This is general electrical components EVs. There is the consider that there are three technology involved are electrical, electronics, mechanical, automotive, and chemical engineering. Actually, and these are three EVs includes it consists of three major subsystem. One is electric propulsion. Electric propulsion is consist of vehicle controller, electronics power converter, and electric motor. Another is energy source. It will be energy management unit and energy source energy refueling unit. Another is auxiliary subsystem that is depending on the auxiliary power supply and steering and mechanical system. That is the electric vehicle drive system. When you are considering, we are connected three, all of these fuel cell, supercapacitor, and battery as a energy source, and connected DC to DC converter with them. Then the DC link is connected all of the DC to DC converter, and that DC link will give the voltage to the inverter DC to AC converter, and that is DC to AC converter control the electric motor will control the transmission. That means the in this way the total this is the in this way the total electric vehicle system can be run. Now the block diagram of electric vehicle powertrain. This is we are considering there are different parts, and that means it grid grid from grid to fast charging converter. That charging converter will give the voltage to using the propulsion battery charger, and onboard charger also connected with the grid, and it is also charge the battery. And upper side we have to consider the super capacitor to control the control the input voltage of DC to DC converter, and the lower DC to DC converter are controlled by the propulsion batteries, which will be charged through the onboard or fast charging. And this is the HVDC bus. That HVDC bus are used to control the input voltage of the inverter, which is control the electric motor. Another is very important, the propulsion system. Electric propulsion system and interface with the transferring energy either direction as required with high efficiency under the control of the driver. And there are different parts. There are two parts are very important, electrical and mechanical. Electric part includes the motor, power converter, and electric controller. Other hand, mechanical is consist of transmission device and wheels. The electric propulsion in major power electronics areas plays a very important role of EVs, and sometimes it is described as a heart of electric vehicles. Now that the power flow in ability due to ability of regenerative power flow also possible in reversible, and this is the functional block diagram of typical electric propulsion system. This is the functional block of the propulsion electric propulsion system. Here, this side is electric controller. Electric controller may be two-way in software and hardware. In software, there are TPLBA, FOC, marks, MRC and STC, BSC and NNC and fuzzy logic. And hardware, we have to consider the microprocessor, microcontroller, DSP and transmitter. And this is the energy system. Energy system already I storage. I already told in batteries and super capacitor, that one, flywheel. And this is the devices, power converter. The power converter are depending on the devices, different type of devices and topologies. That devices are IGBT, MOSFET, G2A, LCT and BGT. And topology we have to consider as DC to DC converter topology, inverter, PWM and resonant converter. And electric motor, there are also two way, that CAD computer aided design, that is APM finite element and EM force thermal and graphics analysis. And type of DC type of the electric motor I will discuss later. The electric vehicle motors, the core element of EVs, apart from the electrical vehicle batteries, which replace the internal combustion engine as known as a electric motor. The rapid development of field of power electronics and control techniques has created a space for various type of electric motor to be used in electric vehicles. The electric motor used for automotive application should have characteristic high starting torque, high power density, and good efficiency. To keep more advanced design requirement and fast charging motor topology, the design of EVS propulsion motor turn to the computer aided design. The another analysis is very much necessary to finding the electromagnetic force and the thermal. That is finite element analysis or finite element method, that different type of finite element method are using for that. That means finite element analysis are using for that. A case of small ANSYS software, that type of software are used for the analysis of the electromagnetic and thermal analysis. And both in GM Impact 4 and Nissan they employ for the induction motor, while both BM E1 and EU200 are used for permanent magnet brushless DC motor, and PM synchronous motor are used for Ford and EXT, the Swiss reluctance motor, and chloride Lucas DC series motor are used for Ties 2, Hijet, and DC Sun motor are used for Mazda Bongo. This is separately excited motor and Fiat, and PM DC motor are Suzuki Senior. These type of are used motor are used for the different companies, are used for the different, and very small number of model in case of all passengers ACB, and a small number of model uses induction motor, including electric cars made the Tesla. And General Motor Company also international design are Chevy Sparks, also Hyundai Sonata, that is permanent mount permanent magnet machine are used. These are the a classification of electric motor drives are used for electric vehicle system. I will not. That means there are commutator, commuterless, and there will be series and DC motor and AC motor actually. That will be self-excited and DC are self-excited and separately excited. There are series and shunt, and this will be the field excited, PM excited, and induction motor also, and synchronous motor, PM, BLDC, switch reluctance motor. These are the different motor are used for. So I will discuss a different motor now. So this is DC motor. Traditional DC motor have been used for electric vehicle system because of their the control principle is very simple. So DC motor, that is also DC motor also use it for the traction because of the high starting torque. For the this is replacing of the field of PM and PM DC motor also are made for this purpose. So now this is the basic construction of DC motor. Everybody knows this one. There will be brass, commutator, armature, and field winding, poles, armature winding, yoke, and commutator. Everybody knows this. That is why I am not discussing all this part. Now I am discussing. There are three parts are important in DC motor. There is three DC series motor, this sun motor, and I already told na DC series motor, this sun motor are used for electric vehicle. Different companies are used. The high starting torque capability of the DC series motor makes the suitable option for the traction application because of high starting torque is possible in this DC series motor. The advantage of the this motor is easy speed control, and it can also with a sudden increase of the load. That the main drawback of this series is the high maintenance due to the brass and commutator. That this is the equivalent circuit of DC motor, and this DC motor series field is connected with the armature, and the resistance RS is smaller compared to the armature resistance. This is the important relation for finding out the or to find out the speed torque characteristic of the motor. And this type of motor flux always proportional to the field field flux will be parallel to that. That is why torque it will be proportional ia square, that will be proportional to ia square. And this is the torque and speed characteristic. There is constant torque, and here is power is changes, and this side is constant power. That constant torque, that time the current will be constant, and due to the flux the current will be constant. Then and this time the it will be going to decrease, means torque also decrease. And DC motor, it is this is the circuit of DC motor. It is the field sun field is parallel to the motor armature, and it will be always connected across to the common supply, DC supply, and sun field resistance always much higher than the armature resistance because of the number of turns of field winding is more than the armature winding, and the phi also proportional to the sun current. This is the important relation to finding out the torque and for finding out the power and torque for the drawing the characteristic torque speed characteristic. The sun motor also known as the constant flux motor, and this is the speed torque characteristic, and this side is constant torque and this side is constant power. Now another motor, DC motor is compound. Compound motor. There are two type of DC compound motor. Why it is known as a compound? Because of there will be both series and shunt field. So long shunt compounder and compound motor, and short shunt compound motor. In long shunt field are connected across the series. Long shunt it is connected with a series, and armature and series field. That means it will be connected with this armature and series field across, and it will be connected with a only armature field. Armature field. They are also classified into cumulative and differential compound motor. These are the DC motor characteristic where uh, we are considering that the current and torque and speed characteristic. Actually, I already told na the B equal to here it is considering EV equal to BL, BA equal to EV plus IRA. So when current will be increased, the torque and speed that will be going to the increase of that. Torque will be increased. This is the sun motor, and this is differential, and same way the speed it will be going to decrease. And this is the torque speed characteristic for different motor. Series motor this will be always decrease, and this is the sun motor, and these two are the differential and cumulative. Now I am discussing very another important induction motor. Nowadays are replace that DC motor and using the AC motor for the electric vehicles. And induction was sometimes called rotating transformer also because of starter and rotor are used as a stationary part and rotationary part. And recently technical development AC motor you are learning the different advantage over higher efficiency, high power density, lower cost, more reliable, and almost maintenance free due to the presence of the brass and commutator. and a high reliability maintenance free operation prime consideration in propulsion. AC induction motor are becoming very much attractive for that EVs. The conventional control of induction motor is variable voltage and because they cannot provide desired performance for the electric. For desired performance, we have to use the FOC field oriented control, or we have to use the V by F control. And induction motor are designed to the efficiency 90 to 95% drawback of this is the drawback of induction motor, that is required the complex inverter circuit. So that application of this Tesla made a Model S and Mahindra Reva use the three-phase induction motor propulsion. That means this is the starter construction of the single phase starter with the winding, and this is the induction motor showing the starter at the rotor slots. And there are two type of rotor are possible in case of induction motor: squirrel cage rotor and wound rotor. These are the squirrel cage and this is the wound rotor. And performance characteristic of induction motor, that we know the equivalent circuit of this induction motor is this one. After the simplification of the equivalent circuit, we have to draw this circuit. That means from here we have to find out the equivalent impedance of the circuit, that is that Zi, and the rotor current IR also we can find out Vs by the Zi. Now the torque equation we are getting from that Td equal to 3 into I square R2 by S. From here you have to find out the torque equation. From the torque equation we have to find out also we have to find out the torque speed characteristic. Where it is the when slip is 1, that means the speed going to the moreover 0, and that in this way it is the maximum torque is going to here. And this is the load, changing the load torque. This is the operating point you have to consider. Now, I already told now B by for the getting better response, better dynamic of using for the electric vehicles and better efficiency, we have to using the B by F control. Actually, B by F control also we have to find out the B by F from the EMF equation of the uh, EMF equation of induction motor. V by F equal to, we can write down the phi, and another part we have to consider as a constant. Then we have to changing the voltage and frequency at the same time that the flux will be constant. Suppose we are considering voltage is 10 volt, frequency is 2 hertz or 20 hertz, then it will be 10 by 20 is zero point 0.5. Similarly, we have to changing another voltage and frequency, then the constant it will be near about the zero point 0.5. In such a way, and also we have to using from the torque equation, we have to use this x s and xr. X is equal to 2 pi ls and xr equal to 2 pi lr. That means lr 2 pi omega is 2 pi f. So now omega is also 2 pi fs. So from here you have to write Vs by omega s. Omega you have to take in common. These are the s is more near to about, then it will be more value, then it will be very less than the inductance value, reactance value. Then that reactance we are considering only L, then omega square. That means we will get omega square. That means V by omega square. V by omega square. So you have to changing V by omega s square means 2 by F. 2 by F. Now 2 by that is constant. Then V by F square. So from here you have to controlling V by F. You have to control the torque also. So now you have to changing way. This is the simple V by F control model. We are considering the variable voltage source, DC voltage, and frequency also variable. Then that will be changed. The frequency, you have to changing the frequency, the speed and torque characteristic. It will be changed in such a way, but the maximum torque will be same. But the maximum torque will be, there will be no changes. Now, three-phase induction motor characteristic when under AOC, then there we are considering the constant flux region, and this is the voltage. Voltage will be variation with the frequency, and linear region of voltage portion with the frequency. The voltage will be boost, voltage will be changing, and the frequency in at a time that it is going to the constant. That means V by F, and torque variation will, that will be the torque variation, and the that will be the current variation with the frequency. Now I am discussing another important motor. Nowadays, so many uh, um, uh, industries are used for this motor. Permanent magnet synchronous motor. It is a rotating electrical machine with balanced three-phase armature and its stator and permanent magnet material on its rotor. Now, the permanent magnet considered employed with electric vehicle technology due to high dynamic performance, better torque speed characteristic, and noiseless operation, high power density, high efficiency compared with other traditional motor. And now, this type of motor also controlled by a three-phase or multi-level inverter, two-level inverter or multi-level inverter also used, or CSI also, current source inverter can be used to control this type of motor. And this type of motor, it is also getting the high power, high performance application. FOC we have to use, or BF control also may be used. And most of the automotive manufacturers use PMSM motor. They are hybrid and electric vehicles. For example, Toyota Prius, Chevrolet Bolt, and Ford. This type of, okay. This is the construction of PMSF. Actually, there are three phase, and rotor is a permanent magnet. So three phase supply is given to the, yeah, and this is the block diagram of that is closed loop. The inverter, two level inverter are used to controlling the permanent magnet synchronous motor, and one position encoder are used to change the speed of the motor, and it will send to the inverter controller to control the switching, every switching. That may be in case of permanent magnet synchronous motor. Actually, this permanent magnet synchronous motor, the input will be the sinusoidal wave. So, to controlling the switching, it is depending the switching of inverter. So that inverter controller control the switching of the inverter. That means there are six combination of switching. There are six combination of switching. That switching are decided by the inverter controller. This is the equivalent circuit of DQ axis circuit. Actually, three phase to two phase we have to consider to for easy process to PMSM machines. And this is the block diagram open loop, that is rectifier, and this is the filter and inverter. And this one already we have to simulate in our college. In myself also simulate this one, and design also, but modeling, not design, it is modeling. Now this is the output when we are considering DC link voltage. We are considering DC link voltage is 96 volt, and we have that means the output. This is the speed with speed, and this is the torque. The electromotive torque is highly increase. After that, it will going to decrease, and similarly the current also, and going to, it is coming to the sinusoidal slowly. It is this one now in a higher range of the time it is coming to the, and this is the output voltage, three phase output, that it is always 180-degree conduction. When we are considering the load variation, then also load variation, also the different time I have to changing the load. Suppose we are given there is 5 Newton meter, after that changing 2 Newton meter, then the fast it will be increasing. Then due to the using the load, the speed are decrease, and then again you have to load is given less, then it is going to the same way the torque we are getting, and this is the current also, and this is the phase voltage. Another also output I got it, but it will be more length. That is why I did not produce here. I am just showing how to changing the load and no load condition in PM SM. Actually, as a load, PM SM are connected in a wheels or transmission. Then it will be speed, and you have to control the speed in such a way. Another motor is brushless DC motor. Brushless DC motor kind of permanent magnet motor. Permanent magnet motor are classified in basis of the shape of the wave shape in their induced EMF, sinusoidal and trapezoidal. When that is sinusoidal, then it will be PMSM. When the trapezoidal, it will be PM brushless DC motor. And it is also connection will be moreover similar to the PMSM, but the input it will be the and it will be the input wave, that means wave shape will be different, and different from the PMSM motor. The motor generally operate shaft position sensor, and because of their inherent high power density, high efficiency, this motor are application for the EV population, and that traction this motor efficiency high around 95 to 90%. And BLDC motor for the high power density it is approached, and many three-wheeler manufacturer using this type of, and four-wheeler also using this type of. This is the cross-sectional view of brushless DC motor. And this is the equivalent circuit. This is moreover similar to the PMSM. That is why I am not discussing here. That means it will be the inverter here, two-level inverter here operate as a 120-degree mode. I will discuss in my next session the 120-degree and 180-degree mode of the inverter. BLDC motor have many advantages that I am given: better speed versus torque characteristic, faster dynamic response, high efficiency, long operating life, noiseless operation, higher speed ranges. And this is also I have simulate total that system drive system of BLDC motor drive system with connected two level inverter. So this is the output speed when we are considering BDC and no load condition, and this is the torque. It is also increasing and then slowly decrease. This is the phase voltage, and this one is the current, and moreover the sinusoidal. I am taken very less time. That is why when I am going to the higher time, then it will be. And this is also load. I have changing load. This is the load at two changes. Then the speed and torque characteristic I have given. And another motor is switch reluctance motor. This type of motor also doubly silent and single excited machine with a independent winding of stator. The stator is similar to the PM motor, but the rotor simpler, having no permanent magnet on it. So that stator winding is diametrically opposite pole are connected in series and or parallel to form one phase of the motor. The stable combination of the stator and rotor poles possible, just like as a 6 by 4. 6 is the stator poles and 4 is the rotor poles. Same way 8 by 4, 10 by 6, 12 6. That are the different code. That means the configuration of higher number of stator rotor pole combination have a less torque reveal. So the main biggest complexity is control. It is the main drawback of this. It is control is very complexity, and in a circuit, and it is also has some noise issue. This is the three-phase asymptotic converter with three-phase SRF. When three phase are connected with the six switches and six diode, and then this is the voltage source. Now these are the phase inductance, and this voltage and that phase voltage and flux linkage. That is the waveforms for that. Uh, these are the main SRM torque and speed characteristic. That means the road increasing the shaft speed, the current limit region persists until the rotor reach the speed that back EMF motor such that the DC bias voltage limitation we can get no more the current in the winding. That means the torque will be going to current limit. That means maximum current limit. Then the torque, then base getting the base speed. After that, the torque is decreasing, is proportional to the inversely proportional to the omega m, means speed. And after that, after at this point of this, then it will be the higher speed, the back EMF increases, the shaft output power begins to drop. This reason the characteristic product, the square, it will be the inversely proportional to the square of the speed. Okay, and this is the speed torque characteristic, and this on the closed loop control of the SRM. So SRM also we have to control the SRM, but this one is the simple. We are considering the controller, and controller gate drive it to control the inverter. It is also similar to the PMSM motor. Controller also similar to that. Now I am discussing the electric controller using for the electric vehicles. The electric vehicle controller electronic, it is the batteries and the motor to the control the electric vehicle's speed and acceleration much like a carburetor does in a gasoline powered vehicles. The conventional linear control such as PI/PID cannot longer satisfy to the rigid requirement placed on high performance of EVs. In recent years, many modern controllers are used for the controlling the electric vehicles. That means model repairing, adaptive control, self-tuning control, variable structure control, fuzzy control, neural network control can be focused for that purpose. And uh, both MRC and STC mostly used for EV propulsion. Using sliding mode, BSC has applied to motor drives. And modern microelectronics devices include microprocessor, microcontroller, digital signal process, and transmitter also used for this. Some microprocessor are used here given, and unlike microprocessor, CPU or microcomputer system, microcontroller includes the resource to serve the standalone single chip controllers. The controller on most vehicles also have system regenerative braking. This is very important for the control. Regenerative braking is very challenging. The regenerative braking is processed to the motor, is used to generator to recharge the battery, and when the vehicles goes the slow down, because otherwise you cannot take the break down this one. During regenerative braking, sub kinetic energy normally absorbed to the breaker and turn into the heat and converted electricity to motor controller and used to the recharge the battery. Okay. Now this is another part of electric vehicles, energy storage system. The energy storage system is very important part of a electric vehicles. Then it is energy storage system mainly battery we have to consider, but there are other things also other than battery. We can also use the supercapacitor and flywheel. So battery, I will tell the battery technology. The battery is there are two different type of batteries: nickel metal hydride families and the lithium ion families. Now lithium ion batteries are used commonly because they are reliable, used and cheaper, and energy efficient. So there are energy storage system is there are three parts. Here is given ultra capacity and energy storage also flywheel also. So electric energy storage system had there are some desirable attribute that high peak and pulse specific power, high specific energy at pulse power, and high charge to maximum regenerative braking and long life. That is very necessary, long life. Otherwise, no, and that will be maintenance cost will be more. The challenge accurate techniques and determine battery state of charge, develop abuse tolerant batteries and recyclability. And this table also the different battery different energy storage lithium metal and lead acid, that means an ultra capacitor that are given different case, and this is the ultra capacitor diagram also. Now this is the comparison of different vehicles for the we are considering that the comparison of this. It is showing the characteristic propulsion system, energy storage system, energy source infrastructure advantage, and I already discussed an advantage. But this propulsion system that also I already discussed. That is the comparison is given for you. Okay, I will send that slideshow. Then for future purpose you have to. Okay, first portion complete করলাম. Okay, hello. After 10 minutes, 15 minutes. Hello. Hello.
I can hear you, sir.
Hello. After 15 minutes, I will start second session.
Okay, sir. Fine.
Okay. After completing my second session, you have to ask question. Huh?
Okay, sir.
It will be better. After second session, huh? I will start after 15 minutes. Mute করবো। কি off করবো? Video.